Alright, welcome back guys. We're going to do 2.5, and as you can see this one is on measures of position. Okay, so if we have a data set and we're talking about a specific value in that data set, what would its position be? And that's when you start talking about percentiles and things of that nature. Okay. We're actually going to start off by talking about quartiles. And let me go over these learning objectives real quick. So we're going to talk about the first, second, and third quartiles of a data set. So when you see that word quartile, think about a quarter. A quarter is a fourth of something. So the first, second, and third quartiles are going to divide the data sets into fourths, like the 25th percentile, 50th percentile, and 75th percentile. Now we're going to find the interquartile range of a data set, how to represent a data set graphically using what's called a box and whisker plot, okay? And then how to interpret other fractals such as percentiles or deciles, although we're really not going to talk much about deciles, but percentiles are used a lot. And then how to find percentiles for specific data entry. And then how to find and interpret the standard score, also known as the Z-score. Okay. So when you hear a percentile, guys, I'll give you an example. So, I think it was about 3 months ago at the time of this recording, she was between 6 and 7 months. My daughter, she went in for her pediatric appointment, and her length, she's in the 60th percentile. Okay, so what that means is it has nothing to do with, it has to do with her length, but not directly. That just means that her length is 60% greater than the length of all the other babies, okay? Or another example would be, if you guys remember taking those standardized tests when you were a kid in elementary school or junior high school, you didn't look at the raw score because the raw score was meaningless. You had to look at the percentile. So if you placed in the 85th percentile, that means you did better than 85% of all the other students that took that test. It doesn't tell you anything about what your actual score is. Okay. But anyway, things of that nature are what we're going to be talking about. All right, so let's start off by talking about these 3 quartiles, and they're going to be denoted by Q1, or Q sub 1, Q sub 2, and Q sub 3. And like I said, they're going to divide the ordered data set into 4 equal parts. About 1/4 of the data is going to fall on or below whatever that first quartile is. And then about 1/2 of the data is going to fall on or below whatever the second quartile is. And guys, I want to point out, we've already worked with the second quartile. We called it the median. It's the 50th percentile, okay? So we've already seen that. And then about 3/4 of the data is going to fall on or below the third quartile. So this is the same as the 75th percentile. But anyway, all right, so we'll do one by hand, but after that we're not going to do any by hand. Okay, so example 1 here, it says find the 3 quartiles of the following data set, representing the number of nuclear power plants in the top 15 nuclear power producing countries in the world. So if you remember finding the median, what you had to do is order the data first, okay? Because the median was the middle. So you can't say that 50% of the data is below this value if you never actually ordered the data first. Okay, so we need to order this data from smallest to largest. All right, so let's do this. Okay, I see a 6, And as you're doing these, mark them off. I see a 7, and then I see an 8, I see a 9, I see a 10. We'll keep going. Let's see. Looks like we've got a 15. We've got a couple 16s. Looks like the next one is 2 20s. Oops. Okay. A 23, a 33, a 50, a 58, and finally a 104. That 104 looks a bit like an outlier. I wonder which country has that. All right, well, what you could do, I'm going to get yellow here, and I'm going to find the median first. So I'm basically going to chop this data set in half. And then from there, I'm going to go and find the halves of those halves. Okay? I'm just going to kind of start marking these off. Now, I'm doing it in this really light yellow so that we can still see the data. Okay, and because we have an odd numbered data set, there will be one right in the middle, and it is 16. Okay, so that is Q2, also known as the median. Now what you can do from there is you can look and see, well, which value is in the middle from that point. Okay, so you could start marking these off again. So here's 6 and 16, 7, 15, 8, and 10, and so it looks to be about 9. Okay, so I'm going to say 9 is the first quartile. Let's say Q1. And then similarly over here, so you got 20, 104, 20, 58, 23, 50, and then 33 is right there. Okay, so 33 is going to be our third quartile. Okay, so you can see here that about 25% of the data lies at or below Q1. About 50% of the data lies at or below Q2, the second quartile, and then about 75% of the data lies at or below 33. Okay, so you could say, in the context of this problem, you could say that roughly 75% of the top 15 nuclear power producing countries of the world have less than or equal to 33 power plants. Okay. Now I will show you, if you guys remember, that you can do this in your calculator. Turn this on. Click on list. I'm not going to use list 1 because I put some other data in there. I'm going to use, doesn't matter, I'll just use list 3. Okay, so I'm going to put this data into list 3. So 6, 7, 8, 9. Should have already had this in here. 15, I think we had 2 16s. Okay. Yep, 2 20s. A 23, a 33, a 50, a 58, and finally a 104. Okay. Alright, so I've got my data in list 3, so I'm going to come back over here to stat and go to calculate one variable statistics, and I'm going to put list 3 in there. So I'm going to go to second stat, and I'm going to select list 3. And then come down to calculate. Now, of course, you know, this will give us the mean of the sample, and give us the standard deviation. And notice, we looked at the median before, but we didn't talk about this Q1 and Q3. So these are the quartiles, guys. It gives you the quartiles right here. So you can see Q1, which is the first quartile, is at 9. The median was at 16. And then Q3 is at 33. Okay. And then furthermore, the calculator will give us the minimum and the maximum data value as well. And Excel will do the same, although I haven't really used it for finding the quartiles before, other than just the median. But anyway, all right, so let's do the same thing with example 2. And I'm going to use the calculator again. So it says the costs of tuition and fees, and these are in thousands of dollars, for 25 liberal arts colleges are listed. And so we're going to use technology to find the first, second, and third quartile. So same thing as above. It's just, you know, you don't want to have to order all this data, guys. So it's easier, you know, to use technology. All right, so I'm going to go to the list, and I'll, well, let me scroll to the right. So see, I put that data under list 1. Okay, so I've already got all that data in here. So I'm going to go to Stat again, calculate, one variable statistics. I need to change this to list 1. And I want to show you another way to do this. Instead of going to Second and Stat to grab your list, the lists are listed above the numbers here. See that in blue? List 1, list 2, list 3, list 4, etc. So I could simply hit Second and click on number 1, and it will put list 1 in there for me. So that's an option. Alright, so I'm going to scroll down, and we can see what these quartiles are. We can see that Q1 is 47, so I'm going to say from the calculator, Q1 is equal to 47, comma, Q2, which is the same as the median, or the 50th percentile, is equal to 55, and then Q3 is equal to 58.5. Okay. And this technically would be in thousands of dollars, right? Okay. All right. Okay, well, let's keep going. All right, so what we're going to talk about next is something called the interquartile range. What this is, guys, is basically, it is a measure of variation. It gives us the range, or the middle portion of the data. And you find it by finding the difference between the third quartile and the first quartile. In other words, you're trying to see how much data is in that middle 50%, from the 25th percentile to the 75th percentile, from Q1 to Q3. Okay, that'll tell you how much data, or the range of that middle 50% of the data. And then you can also get a sense of any outliers using that interquartile range. So once you find that interquartile range, if you then multiply it by 1.5, that will tell you the distance away from this interquartile range that we might find any outliers. Okay, so what you would typically do is whatever that interquartile range is, multiply it by 1.5, and you'll subtract that from Q1, and that'll give you a lower bound. So any data entry that's less than that will be considered an outlier. And then the same thing on the other side. If you take that interquartile range, multiply it by 1.5, and add it to the other end, to Q3, that'll give you an upper bound. And anything beyond that bound, or greater than that bound, will be considered an outlier as well. Okay. All right, so that's actually what we're going to do next. Because example 3 here, it says, identify the interquartile range in this data set in example 2. And then, are there any outliers? Well, we're using that same data set. Okay, so I can refer back here to my calculator. So Q3, the third quartile, was 58.5. Now, remember, this is in thousands of dollars. And then Q1 is equal to $47,000. So the interquartile range is going to be Q3 minus Q1. So if I subtract those, what would I get? I believe that I'll get 11.5. Okay. Now, if we multiply this by 1.5, this will tell us how far away we have to be from that interquartile range before we encounter outliers. All right, so let me get out of this screen. Okay, so 11.5 times 1.5 is 17.25. So the lower bound is going to be Q1 minus 17.25. Okay. Well, Q1 is 47, so let's see what this is. 47 minus 29.75. Okay, so any data values that are below 29.75 are going to be considered outliers. And then for the upper bound, it's very similar, except it's the upper end of that interquartile range. It's Q3 plus that same distance, 17.25. Okay. Okay, so the upper bound was 58.5 plus that range, 17.25. And that gives us 75.75. So that means any values that are above 75.75 would be considered outliers as well. Okay. All right, well, let's look and see here. Do we have any that are going to be outside of this range? I don't see any that are below 29.75. The smallest that I see is 30. We could even look back at the calculator, go back to the one variable statistics. It'll give us the minimum. So you can, oh no, there is one, 19. See, glad I checked that. The minimum value is 19, so this is an outlier. 19 is an outlier. The only other one I see is 30, and it's actually within that range. So now we need to see, are there any greater than 75.75? So I could look to see what the maximum value is. The maximum value is only 61. Okay, so there's only one outlier, and it's 1.5 times that interquartile range below the lower bound, the lower side of that interquartile range, below Q1. Okay, but anyway, all right, and there's something else we can do, knowing the quartiles. We can come up with what's called a box and whisker plot. And I think these are pretty neat. And guys, if you read any research papers, you'll see box and whisker plots of different distributions of data. You can infer a lot from these just by looking at the box and whisker plot. Okay, so in order to make one of these, you need 5 values. You need the minimum, the first quartile, the median or the second quartile, the third quartile, and the max. Well, that's all given to us in the calculator, isn't it? These 5 values right here, that's all we need. And this is also called the 5-number summary, by the way. Okay, and so the way you make this is you construct a horizontal scale that spans the range of the data. Usually the scale starts at whatever your minimum is and stops at whatever your maximum is. And then within this somewhere, you're going to see where Q1, Q2, and Q3 lie. And between Q1 and Q3, you're going to draw this rectangle, and that represents the interquartile range. And then wherever Q2 is, you'll draw another vertical bar, and that represents the median. And then the whiskers come from the distance from the lower bound of the interquartile range, that minimum, and then the rightmost whisker comes from the distance from the upper bound of that interquartile range, or Q3, to whatever the maximum is. Okay? And we're going to actually do one here. All right, let's look at this example 4. I think I've got this data. I still have this data in my calculator. Okay, so I believe that data was in list 3, if I'm not mistaken. So I'm going to go back to stat, I'm going to go to calculate, and I'm going to put list 3 in here. So I'm going to hit second. I'm going to go to number 3, because above that is listed list 3. And I'm going to go to calculate. And scroll down. Yeah, this looks right. See, the minimum is 6. And the maximum is 104. Okay, so this is our 5-number summary right here. Alright, so I'm just going to draw. I'm not going to calibrate this super well. I'll start it right here. I say, okay, let's let this be 0. I'm going to go in tens. This will be 10, 20, 30, 40, 50, draw this out a little bit more. Here's 100, and I'll stop right here at 110. Okay. So what I will typically do is I'll go ahead and see what the first quartile is. It's 9. So I will put a vertical bar right about where 9 is. It's a little to the left of 10. And then I'll find the median. It's at 16, so that would be roughly halfway between 10 and 20, but a little bit to the beyond halfway, so that right there. And then the third quartile is at 33, so it's actually over here. Okay, a third of the way from 30 to 40. And then I'll draw that box. This is my rectangle. This represents the interquartile range. Okay. And then the last thing that you'll do is you'll find the minimum and the maximum. So the minimum is at 6, which is about right here. And that's where you'll make your left whisker. But the maximum, guys, is way over here at 104. So this one has a really long right whisker. But that's what a box and whisker plot would look like. Okay. Now, I'll show you that you can do this in your calculator as well. If you come over, so if you guys have taken algebra before, you know that you use this y equals a lot for graphing functions. But we can also make statistical graphs, but we have to go to stat plot. So you have to hit second and then the y equals. And then what I can do is the stat plot, I can click on number 1, and I can turn it on for one thing. And then you want to scroll down here and select shape that you're wanting. So we're not wanting a histogram, we're not wanting a time series graph, we're wanting a box and whisker plot. Whoops. I think I need to keep going to the right. Yeah, there we go. So I'm going to hit enter. And then you just tell it what you want your X list to be. So that means that X-axis represents what data set. Well, I put all of my data in list 3. So I'm going to put in there list 3. Okay. And then if you go to graph, it will actually graph this for you. So you can see it starts right here at 6. And that Q1 starts at 9, and we actually see it right here. But to be able to actually see all of this, we need to adjust our viewing window. So what you can do is come over here to Zoom, and you can scroll down, and you can go to this Zoom Stat. You enter, and it'll actually reposition this so that you're seeing all of this box and whisker plot. Okay. But anyway, I think that's kind of neat. But guys, after you do this, what you may want to do is go back to stat plot, click on that number 1 again, and then scroll over to turn it off. Okay. So if you don't turn it off and then you try to go to y equals, you won't be able to graph any sort of function. Not that we're going to be doing that in this class, but anyway. All right, so let's look at what we can determine just by looking at a box and whisker plot. So it says if the lines or whiskers are the same in length, then we've probably got symmetric data set, especially if the median is approximately in the middle. Okay. Now you can see here these are clearly not of equal length, those whiskers, and furthermore the median is not actually in the middle. If the right side is long or skewed to the right, then we have a potential outlier, which I think we already knew. And then if the left side is long, or if it's skewed to the left, then we also have another potential outlier. Okay. You can also sort of tell that because the median is closer to the left, most of your data is going to be on the left-hand side. This would actually be a right skewed distribution, because as you come further up here in the numbers, there's less and less data. Okay, so like if it would look something similar to this, it would have a right tail. Okay, because most of the data is kind of down here in these lower values. And in fact, you can see the 75th percentile, or Q3, is right here at 33. So only 25% of, or excuse me, 25% of the data is really beyond that. But anyway, I think that's pretty interesting. All right, guys, and I'm close to 30 minutes, so I think I'll save the rest of this for our part 2. Okay, so I'll see you there. We'll be talking about percentiles.